Hey Kipsters, today we will be covering Module 4, Lesson 16, the computation of the slope of a non-vertical line. It's important that you finished Lesson 15 before you start this lesson. Then take 10 silent seconds to make sure your packet is on this page, just like mine. We started talking about this word slope in lesson 15, and we said that slope is also called our rate of change. I'm going to take some notes at the top of my paper. So slope is also called the rate of change. You can find our slope by figuring out the change in our y's and putting that over the change in our x's, moving from one point or another on a line. In example number 1, we're being asked to use what we've learned from the previous lesson to determine the slope of the line with the following graph. I'm going to zoom in on this graph and you'll notice that we have not been given any points. So we want to be sure that we're picking 2 points on this line where x and y are both integers, okay, whole numbers. And let's label one point P and one point R. So I'm going to pick point P. Point P, I'm going to go ahead and pull it out. Point P is located where? Correct. At point 2, 1. And let's find another point on this line. Let's go with point right here. I'm just finding the label. So point P now and point R. Let's pull out point R. Point R is located where? That's correct. X of 3 and Y of 4. So we want to find the slope of this line in the same way that we found the slope in lesson 16. In other words, what directions and units do I need to move to go from P to R? Well, I know from the last unit that I'm going to need to go up 1, 2, 3 units. So I'm going to go up 3 units. Then I'm going to move to the right 1 unit. So we've answered part B. Then part C asks us to write the directional changes as a ratio to determine slope. So slope is represented by the variable m. So we're going to say that m is equal to our change in our y value. So that's our up. So up of 3. Divided by or over our change in our x's. So that's our left or right. So to the right, 1. Now we know that the fraction 3 over 1 reduces to 3. So our slope is 3. Let's take a step back to see if we agree with our slope being a positive 3. What type of line is example number 1? Is this left to right inclining or left to right declining? All right, you're correct. This is a left to right inclining line, which tells us that this graph is going to have a positive slope. Okay, so because this is left to right inclining, I do agree with my slope being positive. Let's go ahead and now talk about what computation looks like. So when you're computing things in math, you're generally given a standard algorithm, a way of working these things out. And that standard algorithm is going to be the formula for slope, the formula for slope. So I'm going to go back to the top of the page where we started to make some notes about slope. And let's go ahead and get down this formula for slope. So in order to find the formula, the slope of any line, you need to be given 2 points. 1 point P and 1 point R. Okay, in point P, go ahead and label our ordered pair to be P1 and P2. So our X's are P1 and our Y's are P2. Likewise, in ordered pair R, our X is going to be R1 and our Y is going to be R2. When I want to actually compute this slope, is going to be equal to, all right, the change in my y's, so that's actually P2 minus R2 over the change in my x's, P1 minus R1. You'll notice that I started with P in my numerator. I'm also going to start with P in my denominator. So it could also, okay, be viewed as change in y's when you're doing R2 minus P2. So you can switch around those letters. But if I change around the order of R and P in my numerator, I also need to change around the order of R and P in my denominator. So this would be R1 minus P1. So this is the actual formula we are going to be able to use to now compute the slope, So let's go back to example 1. I'm going to go over on the left side of the paper, and I want to first write my formula down. So to calculate the slope of this line, I need to take P2 and subtract R2. I'm going to divide that by P1 and subtract R1. I want to work vertically. So I'm now going to substitute in my given ordered pairs. All right, if you need to label P1, P2, R1, and R2, you can do that on your ordered pairs to help you organize your work a little better. All right, so I'm going to take P2, 1, subtract from it. I'm now putting that over P1, 2, subtract from it R1 of 3. Continuing to work vertically. Now I want to do this math. In my numerator, I have 1 minus 4. Going to be left with a negative 3. Then I have 2 minus 3. Going to be left with a negative 1. All right. Then I want to simplify my last step because I'm working with fractions. And in previous grades, we always simplify. When I have a negative divided by a negative, all right, I'm actually going to be working with a positive. So M is equal to a positive 3. Okay, so using the computation method, I was still able to get that my slope is equal to 3, just like I did in lesson 15. Take a look at example 2. Example 2 says, use what you learned from the last lesson to determine the slope of the following graph. A couple of questions I have for you is, what type of line am I being presented? Is this left to right inclining or left to right declining? All right, this is going to be left to right inclining. Abbreviating a little bit on the right, left to right inclining. So that means my slope is going to be positive. So if I end up with 2 negatives, I know those 2 negatives are going to divide by each other to give me a positive. I know I will not end up with a positive in the numerator and a negative in the denominator because negatives divided by positives are going to give me a negative. And I know my answer needs to end up being positive. So our first step is to find 2 points on the graph. Let's find the same 2 points again. One point P. I found point P located at x of 0, y of 1. And point R. Let's stay a little closer on the line. Point R is going to be located at 1 and 3. Let's use our computational method. Let's use our formula to compute the slope of this graph. Remember, we find slope by taking P2 and subtracting R2 and then dividing R1 and R2 and subtract R1. So let me say that again. We find slope by taking P2, then subtracting R2. Then Miss Matthews messed that up. Slope is found by taking P2 and subtracting R2. Then we're going to divide that by P1 and subtract R1. Want to make sure 2's are in our numerator and 1's are in our denominator. Give you a couple seconds to work ahead of me. Let's go ahead and calculate the slope of this graph. All right, so when I substitute what I've been given, I'm going to substitute 1 and subtract from it 3. And I'm going to substitute in 0 and subtract from it 1. Continuing to work vertically, I know 1 minus 3 will leave me with negative 2. And I know that 0 minus 1 will leave me with negative 1. I know that when I have two negatives being divided, I'm going to end up with a positive. So m is equal to negative 2 divided by negative 1, which will be positive 2. I can double check from the previous lesson and I can count. For me to move from point P to point R, I would need to move up 1, 2, and to the right 1. And when I'm moving to up and right 1, I end up with 2 over 1, which does simplify to a slope of 2. I want to take you back to example number 1 to begin to help you see a tool that lies within this graph that you can use to double check and make sure you're on the right track with slope. And that's going to be slope triangles. It's going to be slope triangles. Specifically, when you're looking at, and let's actually use example number. Let's use example number 1. To move from point P to point R, okay, if I'm using dotted lines now to go from one point to the other, I create a sort of triangle on the graph that connects those points. If I wanted to get to the next point further ahead on the line, all right, I would also need to venture out 1 to the right, and I need to go 1, 2, 3, up. So if I wanted to label another point on this line, okay, point Q is actually going to be located at 4 and 7. Some things that you should know about these slope triangles is that these triangles are actually similar. Because my bases all are going to measure 1 unit, and my heights all measure 1, 2, 3 units. So when I compare my corresponding sides, okay, when I compare my bases, 1, 1, to my heights, 3 to 3. All right, I get an equal proportional ratio. When I cross multiply, 3 does in fact equal 3. I know that these are similar triangles. Take a look at example 2 and create slope triangles on your paper to find point Q. When you found the next point on the line, please type it into the box. All right, so I create one slope triangle by venturing out to the right, going up to get to point R. So I'm going to do the same thing and find point Q. I'm going to venture out to the right 1. I'm going to go up 1, 2. And I find that point Q would actually be located at ordered pair 2 and 5. Ordered pair will be located at point 2 and 5. Slope triangles are very, very helpful when you're working with slopes that are not whole numbers or integers. So in example 1 and 2, our slopes, our rate of changes all end up being a whole number. Let's take a look at example 3. What's different about this line compared to the other two examples? Something that I'm noticing is in examples 1 and examples 2. Both of my ordered pairs P were fixed at some value of 1, either X equaling 1 or Y equaling 1. And specifically, in example 3, that won't necessarily be made to happen. So it lets me know I'm going to have a fractional slope. Let's pick 2 points on this line and call them P and call them R. Pick point P at 2 and 1. Let's pick point R. Point R is going to be at 5 and 3. Now let's use our computations, our computational method to find the slope of this line. First step is to write our formula to find our rate of change in P and R. Slope is going to be equal to change in the Y value, so P2 minus R2, divided by the change in the X is P1 minus R1. Step 2, substitute what we've been given. One minus 3 over 2 minus 5. Step 3, let's go ahead and compute. Let's calculate. So 1 minus 3, I'm going to be left with negative 2. 2 minus 5, I'm going to be left with negative 3. I know in this step, when I see two negatives being divided, I'm going to end up with a positive answer. All right, so I know that slope is going to be positive 2 over 3. Box out our answer. Let's go up to the top to see if our graph agrees with us. That means to go from point P to point R, I should be able to move up 1, 2, and to the right 1, 2, 3 to find point R. I'm going to go ahead and create my slope triangles. Using another slope triangle, please locate the next point on this line. Where is point Q located? I would need to go up 1, 2, and to the right 1, 2, 3. I have to create point Q. Point Q would be located at 8 and 5. So we can have whole numbers as our rate of change or as our slope, or we can have fractional answers as our rate of change or our slope. The goal is, as long as you are identifying 2 points on any given line, you should be able to use the computational method or similar triangle slope triangles to calculate and or find slope. Let's investigate a little more concretely. Let's investigate a little more concretely. In example 4, let's investigate a little more concretely. Let's see if the claim that we can find slope between any 2 points is true. Here you've been given a graph and not given any points. Please go ahead and locate 2 points on the line and label them as P and R. I'm going to label my point P at -4, -3. And I'm going to label my point R at -2, +1. Identify the coordinates of P and R. So I've already done that in my step A at the top. Make sure that you've done that in your part B in your packet. Question C, let's find the slope of the line using as many points as you can. Identify your points and show your work below. I'm going to use my computational method. Step 1 is write down my formula, P2 minus R2 over P1 minus R1. Step 2 is 2. Yep, substitute what I've been given. So I'm going to do negative 3 minus 1 over negative 4 minus negative 2. Notice in my denominator, when I subtracted a negative, I used parentheses to group them so that I don't get confused. I'm continuing to work vertically. I have negative 3, take away 1. Negative 3, subtracting another 1 is actually going to give me a bigger negative. I'm going to end up with negative 4. And now in my denominator, when I am subtracting the negative, I'm actually adding that negative. So this is negative 4 plus 2. I'm going to end up with negative 2. Now I see 2 negatives in my denominator, so I know I'm going to end up with a positive answer. So let's look at the absolute values of these numbers. 4 divided by 2 would give me a positive 2. Therefore, my slope, my rate of change, should be positive 2. Find point Q on the line. See if we can verify computationally that our slope will end up being 2. To create my slope triangle from P to R, how do I move? You're correct. I'm going to move up 1, 2, 3, 4, and to the right 1, 2. So for me to find the point Q on this line, I need to also move up 1, 2, 3, 4, and to the right 1. Label that point Q. We'll go back down to the bottom, and I am going to compute now. Let's use point R and Q. So our formula will change up. I'm using points R and Q. It's actually going to be R2 minus Q2 over R1 minus Q1. Substitute your given values and verify that your slope is 2. I've used points R and Q to verify that my slope or my rate of change, moving from one point to the other on this line, is 2. Let's talk about horizontal lines. Let's talk about horizontal lines. So we said in the previous lesson that horizontal lines have a slope of 0. So suppose you are given a horizontal line in the last lesson. We're going to expect the slope to be 0. But let's give points P and Q, points P and R some numbers so that we can verify. If you're thinking back to lesson 15, we said that horizontal lines are represented by what equation? You're correct. Horizontal lines are represented by the equation y equals c. That means y is consistently the same number no matter what our x values are. So let's give p an ordered pair and r an ordered pair that has the same y value but a different x value. Let's make p located at x of 2 and y of 3. And let's make r, so r is a little further down the line, so it's going to have to be greater than 2. Let's choose 8 over, 8 and 3. Remember, our y has to be this constant, the same value. So our formula is that P2 minus R2 divided by P1 minus R1 will give us our slope. Remember, this is a horizontal line, slope should be 0. Let's go ahead and substitute what we've been given and compute the slope of this line. Next step looks like 3 minus 3 over 2 minus 8. Simplify 3 minus 3 is 0. 2 minus 8 gives us a negative 6. So let's ask ourselves how to interpret this answer. 0 divided by negative 6. 0 divided by any number is 0. So we have proven that we can use this formula to calculate the slope for all types of lines, including horizontal lines. Go ahead and locate your lesson summary to answer some of the questions below with me. We know that the slope of a line can be calculated by using any 2 points on the line. Why can we do this? What tool can we use? Type your answer in the box. Hopefully you said the tool we can use is similar triangles or slope triangles. I'll take either of those answers. When we move from one point to another on the line, we form these similar triangles that are going to be equal in ratio. They're going to be equal in ratio. Slope is referred to as the difference in what values compared to the difference in what values. Hopefully you said y values compared to x values. Okay, we're looking at how much we rise over how much we run. And then I want you to go ahead and make that note in your lesson summary box. Slope is equal to our rise over our run. Connection to signs, that's the change, the delta, in our y values over the change, the delta, in our x values. Last key point. The formula to calculate slope is what? What does that formula look like? Is there only one way I can write this formula? If not, show me the other way. All right, plus 2 opportunities. The slope of a horizontal line is always, you got it. The slope of a horizontal line is always 0. And that brings us to the final point in our lesson summary, that the slope of a vertical line is undefined. Okay, it is not defined. Thank you for your grit and attention today. Please be sure that you've turned in what you've needed to turn in to me, and that you've done your exit ticket and independent practice. Be sure to go back and watch anything as needed.